Hey guys, this is Craig Migliaccio with acservicetech, and today what we're going over is what is Delta T. You hear that term thrown around a lot in the HVACR field, and in this video I want to go over what the Delta T temperature should be for during air conditioning mode and also in heating mode. So the Delta T is the actual change in temperature between the return duct and the supply duct, and in this case we're using a dual temperature meter and we're sticking our small K-type bead temp sensors into the holes, and what we did is we just drilled 1/4-inch zip screw holes into the ducts, and that's how we're taking our reading. So on this temperature reader we're actually able to take a differential reading between the return and the supply by selecting the T1 minus T2. So we have the system running right now, and our Delta T is roughly 19 degrees between the return and the supply. And so this system should have about 18 to 21 degrees as its Delta T because it has a TXV at its indoor coil, and the outdoor unit has good fins. It's a 16 SEER unit. So this one should have 18 to 21 degrees as long as it has good airflow. But I want to go over some scenarios when you may not have 18 to 21 degrees even if the refrigerant charge is good. So I'm going to go ahead and shut this unit off now, and we'll go ahead and get into that. So some systems that have a piston or a capillary tube may not have 18 degrees. It may be 16, it may be 17, and we go into the detail of explaining Delta T in our book if you haven't got a chance to check that out. And also we have our quick reference cards where we have a section on Delta T itself, as well as checking the refrigerant charge and weights and PT charts and things like that. But over here on our Delta T, we have a couple notes just to remind you. If you have a lower than 18 degree Delta T, it could be a low refrigerant charge, but it could also be that you have high humidity in the building. So you could have a high heat load in the building, and remember that a fixed orifice can't let more refrigerant into a system in order to handle a higher heat load like a TXV can. So even though your refrigerant charge is good, you may just have an extremely high heat load, and you just don't have enough saturated refrigerant in that evaporator coil to absorb that amount of heat. So you have a high superheat. So we have some different notes here on our quick card, so check them out over on our website. But you also could have something where you have a low capacity in the system. So for instance, maybe you have a deteriorated outdoor unit and your indoor unit's at a lower airflow. So you may have 18 to 21 degrees, but just because you have a outdoor unit that has 24,000 BTUs on the model number, that does not mean that you're removing 24,000 BTUs of heat from the building. So you may be at a lower capacity. So maybe your refrigerant charge is low, but also your airflow is low. So that could be an issue as well, even if you do have the correct Delta T. So you really want to monitor the total superheat and the subcooling when you're checking the refrigerant charge. If you measure higher than a 21 degree Delta T at your indoor unit and you have a single or two-speed outdoor unit, you could have low airflow. So that could be the issue. And what that means is basically you're not providing enough heat from the inside the building, which is the heat is in the air. You're not providing enough heat across the evaporator coil for the refrigerant to absorb. So because of that, you end up having a potentially higher Delta T. So you could have 23 degrees or 24 degrees. It's a telltale sign that you have low airflow at the indoor unit. Now, if you have a mini split unit, they tend to have more of a saturated state in the evaporator coil, and they have a lower superheat. So they're able to absorb more heat. And so you will have maybe, say, 20 to 24 degree Delta T on a mini split unit. So I just want you to be aware of those things. Now that we covered the air conditioning side of the Delta T, I wanted to go into the heating side. And so you can use the Delta T measurement to make sure that you're not overfiring or that you don't have low airflow. You want to make sure that your Delta T measurement is steady. So once that furnace is on and the blower is on for say 5 minutes or something like that, you want to make sure that your Delta T measurement is steady and it's not climbing. Because if it is climbing, whether it's an air handler or a gas or oil-fired furnace, then what that means is you don't have enough airflow to reject the heat into the building. And so you're going to have one of your limits is going to trip, and it's going to stop the ignition, or it's going to stop the electric strip heating from providing the heat, but it's going to allow the blower motor to continue. So this is usually used on a oil-fired furnace or older gas furnace. And this is a fan limit switch, and you have your third knob right here. That's your high temperature limit. So this would shut your ignition off on a gas furnace. You also have on gas furnaces something that may look like this, and it's a temperature limit, and it's near the heat exchanger area, and this will open up if the heat becomes too high because you're not able to reject it into the building. Maybe your blower motor is bad, something is broken, or the capacitor is bad. So this is going to be a safety to keep your gas furnace safe, so it's not just continuing to overheat. On a furnace or a air handler with electric strip heating, you could have a sensor such as this right here, and once again there's your thermal limit, and in this case it's 145 minus 40. So this will be normally closed, and then it would open up if you got higher than 145 degrees, and it's not going to close back down again until you go 145 minus 40. So it's not going to close the electrical connections again until you get down to 105 degrees. Now on a gas furnace, a thermal limit may have a higher temperature limit. It may be closed up until it gets to 180 degrees or 200 or 220, and that's when it may open up. So the manufacturer will design the system for the correct thermal limit for that system, just to keep it safe. Just so you know, you can measure your CFMs by taking a delta T measurement, a voltage measurement, and an amperage measurement. That's called the temporized formula, and we have a link to a video on that down in the description section below. You can actually do the same thing for a gas furnace or a fuel oil-fired furnace, and in order to determine the actual airflow. Now we're going to go ahead and get into our air handler, and we're going to actually turn this air handler on, but we're going to be turning only the electric strip heating on and not the heat pump. So now we have our air handler running in heating mode with just the electric strip heating, and we see that we have a delta T of 21 degrees roughly. So that should be remaining fairly steady. It should not continue to rise. It should just be at that same level the whole time. So that's different than if you had a heat pump running in heating mode without the electric strip heating. That's going to vary greatly. The delta T is going to vary greatly depending on the outdoor temperature and if the outdoor coil has frost on it. So you got to remember that the outdoor coil, the refrigerant flowing through there, has to absorb the heat there in order to reject the heat at the indoor unit. So you're not going to have an exact temperature for the delta T for what that should be. So it's going to depend on the outdoor temperature, and usually you have your outdoor heat pump running, say it's 50 degrees or 55 degrees, it's going to have a much higher delta T at the indoor unit when the outdoor temperature is 50 degrees versus when the outdoor temperature is maybe 30 degrees. Then your delta T at the indoor unit is going to be much lower. So it has to do with the amount of heat that the refrigerant is able to absorb outside. If you want to learn more about checking the refrigerant charge and delta T and troubleshooting air conditioning systems and heat pump systems, check out our refrigerant charging and service procedures for air conditioning paperback and ebook, and also our quick cards. So our quick card references, they're made out of polystyrene, they're flexible, they're able to handle the heat and things, but you can use them as a quick reference in the field. You could also use the book or the ebook as a quick reference in the field, but you can check them all out over at our website at acservicetech.com, and we have our paperback and our quick cards also available over Amazon.com. Hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.